Welcome back to Cloud 42, I'm James. Today we're continuing work on the Toolpost grinder. This will be part 11. Hopefully today we can finish up the motor clamp. All we have left to do is to drill it, tap it, and counterbore it for the clamping screws, and then get out a slitting saw and slit it so that it can clamp down on the spindle and the motor. Let's get things loaded up on the mill and get started. Okay, we need to set this up so that we can drill the holes perpendicular through the slit and so that we can slit it. So this slit needs to be horizontal. And I had originally been thinking that I could use this engraving line in order to get this horizontal, put something with an edge on it in there and set it on top of the mill vise. And then I realized I don't have to do that at all because I have these vise jaws that I already cut to fit. So if I just lay a vise jaw down in here and set it on top, it comes up exactly horizontal. So that's really easy. Grab a vise handle here. So that's that job done. That's all we have to do. It's all set up. This is horizontal. We don't even need to check it because this was milled to match that part when we decked off the back side. Okay, so now we just need to locate our zero, and I'm going to locate the zero in the center, the Z0 at the highest point, and the X0 at the furthest left point. Okay, there's the back. We'll set Y0. And here we'll set Y divide by 2. We raise it up slightly just to make sure we're contacting on the tip. And we are. And I will 0x with the offset from here. Now I'm going to lower it slightly and check again. Yep, that's good. Okay, now set the Z0. We're going to do it off of the highest point here. That looks about right. Let me get my shim. And there it is. That looks good. Okay, let's talk a little bit about order of operations. So we've got to drill a hole full depth in here that's going to be threaded in the bottom, and then a larger hole partway down, and then a counterbore at the top. We don't have a flat surface to start with, so we're going to start with the counterbore. We'll helically interpolate the 2 counterbores and put those in with flat bottoms and then spot the drill holes in the bottom. Then comes the question, what do you drill first? Do you drill the larger diameter halfway down and then the smaller diameter in the bottom? Or do you drill all the way to the bottom first and then enlarge the hole? So I am opting to drill all the way to the bottom with the tapping drill first and then enlarge the top part of the hole with a larger drill. And the reason I'm doing that is I don't want space in a larger hole around the smaller drill bit, because then the smaller twist drill, as it's going down, is going to be pulling chips up, and they'll be able to escape the flutes and get around the smaller drill in that larger bore. I don't want to risk that, so I'll just do a deep peck drilling cycle all the way to the bottom with the narrower bit, and then with the slightly larger bit come back and enlarge the hole, all after we do the counterbores. So first step is to interpolate the counterbores. So let me get a carbide end mill. This is a 1/4 inch carbide end mill, 3 flute, polished specifically for aluminum. We'll run this with air and coolant, mostly air just to get the chips out of the hole. Okay, that's the counterbores. Next thing we need to do is spot the holes. Grab a spotting drill. Next up is the tap drill. This will go all the way to the bottom of the hole. try to angle this to make sure we get some coolant down in the hole. Okay, that's the scary drilling operations complete. Now we just need to enlarge the top part of the hole. There we are. That was a little bit stringy, but we got it done. Let's test with the screws. Yep, that looks about right. They go down and hit the point that's going to be threaded later. Okay, the last step is to chamfer the top of these holes. Now this is a 1/2 inch 90-degree spotting drill that I use as a chamfer mill. We do a nice little 3D chamfer around the top of the holes. It's actually an offset trace operation in Fusion 360 to do this. And there we have it, beautiful 3D chamfers at the top of the hole. Next thing you do is go ahead and slit it. Okay, let's get a slitting saw. Okay, this is a 40,000 slitting saw. It's about 1 millimeter. And the diameter of this saw looks like 2 3/4 inches. Torque this down so we don't spin it. Now, the system knows the length of this. This is tool 103, so I'll just go ahead and select 103. And I know off of the cam model, I want to come down to a Z height of -1.501. And that should line the saw up perfectly with this, but we're going to check to be sure. I'm checking to make sure I don't collide here. That would be bad. Hopefully we'll clear this vice jaw. If not, we'll have to change the setup. Looks like we're going to need to change the setup. Okay, I've got some parallels in underneath this now. 1/2-inch parallels have raised it up, so instead of being -1.501, now we're just at -1.001. And the saw appears to be lined up with the groove, so let me get some coolant going here. We'll run this nice and slow. We'll run this down around 500 RPM. Let's get it over close to where we want to make our cut. Okay, I'm going to slow this down and we'll make the cut at around 1 inch a minute. Let's see how that goes. I'm going to set this up and get some coolant going here. I don't need very much air, just coolant basically. Okay. I'm going to look and see if we've broken through the other side. And it looks like we have. Okay, so now I can make the cut across horizontally. Okay, I think that's it. Let me check and be sure. Yep, it feels like we're through. Let's come out of the cut. That looks great. Get this out of the vise here, see what we've got. Oh, that just looks beautiful on both sides. I don't see any remnants of the engraving line at all, which means we hit it dead on. I'll wipe this off and we'll deburr it over at the bench. As long as we have this set up, we might as well take this opportunity to slit the motor eccentric. Now to get this score line horizontal, I'll bring in a parallel that I can use to align it. That looks good. I could go up just slightly. This by no means has to be perfect, but this is going to be just fine. Get a good grip on it so it doesn't go anywhere, and then we'll come down, line up the saw, and cut through this side. I think I'm going to slow it down a little bit more because it's steel. We'll run about 200 RPM here. And we can slow down if needed. Yeah, I'm going to slow it down a little bit. Let's go to 0.4 inches a minute, see how that goes. That seems all right. And as usual, slitting saws never run concentric. They're always a little lumpy. Okay, we're a little more than halfway through now. Now I don't know what this eccentric is going to do. It's DOM tubing, so it certainly had a lot of stress in it when it was made. When this pops through, I don't know if the eccentric is going to pop open or closed. But either way, I'm going to be ready to stop the mill. Okay, looks like it popped open ever so slightly. Looks nice. That's also going to need a little bit of deburring, and we'll do that over at the bench. Okay, that's deburred. The other thing I need to do with this one is I need to tap the holes. So I've got a 1/4 28 tap here, and it's spiral flute. Even though there's not a lot of room for anything that's in the spiral flutes, there's no room for them to move at all, but the hole's shallow enough they'll just pack up in the grooves and we should be good. Let me get a little lubricant. This is aluminum, so I'm going to use A9. And we have a built-in tap guide here because of the way the hole is, because of the geometry of the hole. Okay, that's the bottom of the hole. There must have just been a chip in front of it. Made it feel soft. Okay, and the other hole just like it. Okay, these are the 1/4 28 clamping screws, and I've got a couple different ones here. It's like one of them's 1 1/4 and the other one's 1 1/2. I like to use the 1 1/2 just because of the clamping force. I'd like to have more thread engagement. Let's make sure we can get these clear to the bottom of the hole without binding on the bottom. Looks okay. Oh, there we go. I'll just run these down. Oh yeah, that's clamping. Let's see how much we can clamp. Okay, that one will go pretty much bottom it. Same way there. Okay, well, let's see what we can clamp in this thing. got the spindle here. Oh yeah, that's beautiful. That grips it nicely. Let's put in the eccentric here. There's the eccentric, and slide in the motor. Eccentric seems pretty stiff. Let's see if we can clamp it. Enough to close it on the motor. Oh yeah, no problem. Those are both solid. Well, that is the motor clamp done. I'm going to call that a rousing success. I do think we need another operation on the eccentric to put in a pin so that we can move it. Let's take it back over the mill and put in a hole. Okay, I have a mini pallet set up in the vise here because we need to drill a hole through the eccentric, and I thought this would be the easiest way to position it. Now, I've marked and center punched a hole, or a mark where I want to drill the hole, but I'm going to try to get it centered up on that, and then I'm going to use an edge finder to center it within the piece here. But first we need to figure out how exactly we're going to lock this down. Now I have an engraving bit here in the mill, and I'm just going to use that in the center punch to kind of locate this part generally where it needs to be. Okay, that looks pretty good, and I'm just going to lock the quill there just to hold it in place. Let's get some clamps. Okay. Those are good and tight. That's not going anywhere. And I've got it slightly off the edge of the mini pallet so we can drill through without damaging it. Not that it really matters that much. Okay, let me grab an edge finder. Okay, that'll be X0. And X divide by 2. So then if we dial over to X0, that should be right in the center and exactly where we want to be. Let's check the hole. This is a 125 gauge pin, and that fits perfectly. Check 126. Won't even start. Okay, we got the eccentric drilled. There's the drilling raised a little burr, so I'm just going to take that off. This is a little Noga rotary countersink. Let's grab great for deburring these little drilled holes. There we go. Nice and clean. Okay, let's put this together. I've got the spindle clamped up with a V-block here in the vise so that it's held securely. Put the motor clamp over it. Insert the eccentric. Put the motor in, and we'll just clamp this temporarily to hold it for a moment. Now, let's put the belt on. Belt goes on easily at this spacing. And now we just have to rotate the eccentric to put the motor in the correct position to tighten up the belt. Loosen the screws. There we go, nice and tight. This will be easier when this is mounted in the lathe because we'll actually have it horizontal and we'll actually have this mounted in something. And there we go. That is the tool post grinder. That's the motor clamp. That is beautiful. And the belt drive is just silent. Well, that's it for today. Next time, I think we'll start on the tool post clamp that'll hold the spindle onto the lathe. Thank you for watching.